Good morning. We're getting ready to watch a master of test strategies take this practice SOL. Pay attention, maybe you'll learn something. So I'm getting ready to start sharing my screen. Okay. So first off, if we don't already know how to do this, let's make sure we split screen properly. Multiple ways to do it. Quickest way is get the screen you want to move left or right, hold down your Windows key on the keyboard, and hit the left or right arrow depending on which way you want to go. And you do the same thing for the other one. I like having my calculator on the right. Perfect middle split screen. You can do it however you want. That's what I'm going to do. So let's roll. All right. So this is all about testing strategies, maybe moving kind of quick. But the beauty of a video is you can stop and start it whenever you want to. Okay. So go ahead and get started here. I see number one. As soon as I see number one, I'm looking at a lot of stuff here. The first thing that stands out to me is that little thing right there. But also, I'm also going to do some elimination. I'm going to ignore all these variables, and I'm just going to go with what I see as far as whole numbers are concerned. 22 divided by 11 to the power of 0, because I know that's going to be a 1. As soon as I see 22, that means 22 over 1. I'm looking over here at my answers. The only thing I see 22s on is right here and right here. So already I've eliminated half of it. So how do I go from here? Well, look at what's here on these answers. All right. We have y squared on top, and we got a y fifth on top. Look at what's left up here. We should know that we can't have negative exponents. So if we see that, they got to drop. There's only a 1 down here on the bottom at this point. So the only thing coming down is that x, because it's got negative 7. Look here at this answer. We got x to the 5th here, x to the 7th here. That one looks correct to me. So my answer is B. Moving on. All right, again, we have another one of these radicals, the simplest form things. I'm ignoring everything and just focusing on the actual numbers, the whole numbers. So one thing I do know is I have a square root symbol right here, or my radical. Put square root of 27, okay? Now, do that for my answers. Now, I shouldn't have to do that multiple times because I do have some repeats. So for A, I got 3 on the outside. Back that up a little bit. 3 square roots of 3 on the inside. Okay, look, I got a match. So that counts for A and B, which tells me I don't have to worry about C because C is just going to be 3, which certainly doesn't match. And then that last one, just to see it, I got 3 on the outside for D, and I got a square root with 9 on the inside. Does that match? No. So the only things I'm looking at are right now A and B. That's the only thing I'm concerned about because those are the only things that match. So again, I got to know something about square roots. So let me back all this up here. All right, let me slash these out. I eliminated those. I wish I had a better marker on this thing. Anyway, I'm looking at A and B. So since these are square roots, I know I'm taking out pairs. So if I see anything that's odd, that means I'm going to have something left over inside. Well, look at the difference of these answers here. That's an odd, that's an odd, that's an even. That tells me the only thing that should be inside is that Z, or sorry, taken out is that Z. I should have an X and a Y left over. I only have that for B right here. So B will be my correct answer. I really need a better way of doing this. There we go, B. Okay. So again, you just need to know about pairs and radicals there. Eliminate. Moving on. Okay. Number 3. Talking about completely factored. All right. Throw this in the graphing calculator. I'm not even sure I want to waste any time with this, but since we had people miss this, I guess I'm going to put that in there real quick. Put exactly what you see. 4x squared. All right. Minus 11x plus 6. All right. Look at me. I got a pretty graph. Now, 2x, this is A, plus 2 times 2x plus 3. All right. And there we go. I left a little space in there. There we go. That clearly didn't match. I'm going to start speeding this up. 2x minus 2. 2x minus 3. Okay. Did that change anything? All right. Oh, I did the subtet again. Minus 3. Here we go. All right. It's getting closer. Still no, though. All right. So get rid of that. I'm now on C. X plus 2 and 4x plus 3. All right. How did that get in there again? X plus. There we go. Okay, that didn't match. So theoretically, that should be my final answer down there for D. 4x minus 3 and x minus 2. Oh, there's my match. And just in case you didn't see it, turn it off right on top of it. There's my answer. That is D. Moving on. All right, word problem, scary. Come back to it later. That doesn't mean don't do it. That just means we are skipping it for now. Word problems are scary, right? Okay, looking at number 5. I can graph this, but there's one little problem. We got people that miss this thing. You need to know what this word means. Quotient. Quotient is related to operation of division. So throw that division sign up there and then start graphing. 18x squared plus 15x minus 18. All right. Now throw everything on the bottom. And what I have on the bottom is that second part, 3x minus 2. By the way, this is designed. If you throw all these in there, you're probably going to find a match for something that's wrong because you did the wrong operation. But anyway, I'm now graphing A. Let's see what A looks like. 6x squared plus 9. Okay, interesting. B, 3 times 2x plus 3. Interesting again. You see it? Right on top. All right, let's go to that last one. C, 2x plus 3 and 3x minus 2. All right, where'd that red one go? Okay, doesn't match. D, 6x squared plus 5x minus 6. And I always double check things. All right, that don't look like it matches anything. So let me turn this purple one off because that didn't match. My original was green, and I believe it was this one here. Yeah, black line right on top of the green one. There is my answer. That is B. All right, keep it moving. Okay, simplified form. All right. Guess what? I see X's and Y's in here. I bet I can graph this thing. Let me put that original in there. Parentheses. And as soon as I see that, I also see a divisor bar. So on top of the divisor bar, we got negative 2x to the third. All right, bring it on down to the basement. And we have a y squared in there. And let's get that closed parentheses. And outside, we have a negative 3. All right. So, oops, we got a little flag here. What's it say? Equal sign, turn this into an equation. Okay. It does not say add equal x, so we already have x in there. Let's give it a value. I don't know. Let's say 2. How about that? Ooh, look at that. We got something funny looking there, but it doesn't really matter. All right, let's go to A, negative. And then we got that again, y to the 6th, and go down to the basement, 8x to the 9th. All right, and that's all there is, but we got that thing again. If we put this up here, we need to be consistent. Put an equal sign. We use 2, use the 2 again. Uh-oh, that's right on top. That's interesting. Keep going with that. All right, B, 6, y to the 5th. All right, I forgot to put my divisor bar. That's okay. Another method's highlighting. There we go. All right, y squared, no, sorry, x to the 6th in the basement. And that's the whole answer except add that equals 2 out here. Okay, that clearly doesn't match. So still moving on. We're on C now, negative divided bar. All right, up top, I got y to the 5th. Bring it down, and I got 6 x to the 6th. All right, don't forget to add that equals 2. Oh, we got a line, but that one clearly doesn't match either. All right, go back to the last one. We're on D. Negative divider bar 8x to the 9th. I'm down to the basement. Y to the 6th. And again, for consistency, equals 2. Awfully close, but not a match. So where was our match? It wasn't here. Oh, there it is. It wasn't this one. This one did. And that is A. A was our answer. Moving on. Ooh, scary words. Moving on. Come back. Mark it later. Oh, number 8. I see lots of words. I'm going to move on. I don't want to do that one either. All right, 9. All right. This one should be pretty straightforward. All right, I see this cube root of question mark equals 3 cube roots of 5. Question mark means that's where one of these answer goes. Okay, so let's see. I'm going to put this part up here in Desmos first. 3, and don't forget where the cube root is. Cube root is over here in that functions menu all the way at the bottom. There it is. For that n, that's where you put your number. And then inside, there's a 5. Okay, so let me set this up one more time, get my cube root symbol, and cube root. Now to start putting stuff inside one at a time. Is it 15? Does it match? No. What's next? 45. Does it match? No. What's next? 135. Does it match? Yes. Let me check D just to make sure. 175. Does it match? No. Come back to 135. 135. C is our answer. See how easy that was? All right, moving on. Oh, not lots of words, but this is something we may or may not have seen. We'll come back to it. All right. 11. 11's a lot of fun. What is the value of this? And then it goes and gives us these values here. A is 8, B is 2, and C is 1/2. Well, if we learned anything, we should probably put that in the calculator. And since we're substituting, don't forget parentheses. It may or may not matter, but let's assume it will because it won't hurt. A and then C is 1/2 in parentheses 1/2. And don't forget, make sure you come back out, get the whole thing in there. That said 8c squared, so we're going to put that squared out there. All right, the next thing is minus 2 cube roots. So minus 2 cube roots. Let's go down here and function again. Put that 3 in the index, come inside here. All right, so it's cube roots of A, and A was 8, so 8 needs to go in there. Now, you may or may not need to do this, but I'm going to do it anyway for consistency. 2 minus 2 cube roots of 8. All right, so now we're past that. Make sure you come outside the radical. Next part is minus sign, and then we have those straight up and down lines. That is our absolute value. So inside absolute value, we got 3 times b, and whatever b is, it's going to be in parentheses, and that's a 2. Close it out, and I have a minus 7. And then that's the end of my absolute value, and I have an answer there. That gets pretty clear. -3, is that in one of my answer choices? Yes, it is. And I triple checked everything. Everything there's right. There is my answer. Moving on. That's easy. Too many people miss that. Okay, I see. This one was one that we've talked about with some people. This was a poor design. We're going to skip it. Plus, I do see lots of words. Okay, now this one kind of sort of has some words, maybe, but it's not. I don't view this as a difficult one. Let's do this anyway. I'm reading. See, I see slope. I see passing through this point. I also see and having an x-intercept of 2. Well, it gave me 2 points, folks. So there's several ways I can go about this. First thing I'm going to do is I'm going to start graphing my points. All right, my first point is -1 and 3. All right, there it is in red. Now, since I have an x-intercept of 2, that means I have a second point, and I know an x-intercept has to have a value of y of equals 0. So my x is 2, x comes first, and then it's going to have a 0 on the tail end, and there it is. Okay, so I got 1 point, a -1, -3, and I made a mistake. I saw it, that's why I double checked. -1, 3 needs to be -1, -3. It did change. All right, -1, -3. And 2, 0. There's my x-intercept right there. All right. And let's see, somebody told me about this, add steps. I think it was steps of 1. Is that right? Let's see if that did it. I'll worry about that part later. I can zoom in. There we go. All right, so now I can see there's my 2. And don't forget, you can turn these labels off and on too. All right, so I know that's my x-intercept of 2. Now, the question is, what's the slope? Well, as soon as I see these 2 dots, if I were to draw an imaginary line, I know it's positive, so that immediately means it's not going to be that one. Can't be that one, all right? So that leaves me with B, C, and D. All those are positive. Now, all I got to do is count, all right? It's not the only way, but here we go. 1, 2, 3, rise, over, 1, 2, 3, run, 3 over 3. And if you don't know, check it. 3 over 3 is 1. Is that one of my answers? Yes, it is right there. So the answer is C. Look how easy that was. All right, moving on. Okay, so now we're on number, is this 14 already? Boy, it is. We are rolling through these. All right, so 14. This one, I'm going to say it was kind of sort of new. It's a little bit of factoring. We're going to mark this and come back to it. All right, 15. Too many people missed this one. All right, so what is the solution to all this mess here? All right, well, I'm going to graph this thing. So -2 parentheses, and then we got 4y, and then we got -3, and then close parentheses. We got the greater than and equal to, and then -1. I have a wonderful shading there, so double checking, -2, parentheses 4y minus 3, greater than or equal to -1. And it's a solid line as it should be with everything underneath. So all I need to do is start graphing these. Now, ignore that y colon part. Don't worry about that. All right, all I see is these things here. Now, since these are all solved for y, you might be able to infer something from this. Since y is less than, you might infer that that means it's going to be less than, like below. But I'm also looking at this less than or equal to. So is there anything missing the or equal to sign? No, they all have it. So I'm going to start with my B, and I'm going to start with my D. All right, that's because they got that less than or equal to. Let's see what happens. All right, so I'm doing B first. Y is less than or equal to 7/8. Oh my gosh, so that's a perfect match already? Yes, it is. All right, let's do D just to make sure. Y is less than or equal to 5/8. Close, but not close enough. Clearly, that B was the answer right here. There is my answer. B. Some people made this too difficult. I don't know why, but moving on. Ooh, lots of words. We'll come back to that. Scary, run. Okay, so next one up. Radicals again. Hey, no problem. Radicals are easy. We should be Teenage Mutant Ninja Turtles. Radicals. This should be easy. I'm going to ignore everything except the whole numbers. All right. I see that 3, and I see a square root of 5. Let's put that in there, see if we can't do some elimination. 3 square roots of 5. All right, ignoring everything else. Now, notice that I got A, I got that 30. B, I got a 15. C and D have a 45. My eyes are drawn here because oftentimes, for test taking purposes, that means those are going to be close. So you know what? I'm not going to skip these to make a point, but I am going to show them anyway. So A is a square root of 30. All right, is that going to be a match? Nope. Matter of fact, I'm just going to delete that. Normally I don't, but I am this time. All right, so square root of 15 for B. Nope, not a match. I know 45. It's got to be 45. Yeah, so 45. We have now eliminated B and A. So we are looking only at C and D. So now we got to know something about our square roots and our matching pairs, okay? So we're looking for the equivalent expression. So both of these are, right? And I believe it said, let's see, one of these is going to have the right mix. All these are inside, so that means that these got taken out. I can look at it any way I want, okay? So since this had things left over, that means that there were odds in there, C, D, and G. C, D, and G, C, D, and G, they're all there, okay? So I see a 1C, so that doesn't help. 1C here, 1C here. I got 2 Ds and 3 Ds here. I got 1 D here and 1 D here. Now remember, out here, one of these letters represents a pair. So if I put that inside, that will be d to the third. Now, the only one that has d to the third is this one right here. All right, but let's keep going. Let's look at the g's anyway. All right, up here, I got g out here, and I got two g's here. This one has g3. That one could not be matching this, because if I put these inside, remember, these are two pairs. Two pairs, 2 times 2 is 4. That means I'm going to have 4 g's inside with a fifth one already in there. That's what's going to match D, which is our correct answer. That wasn't hard, was it? Square roots, got to know something. All right, now this one looks kind of difficult, but I'm going to come back to this one anyway, because this does look a little scary, but this was harder. People made it harder than it was. We'll come back to 18. All right, 19. All right. What are the solutions of the equation? Well, as soon as I see that, that means something. So let's come back to it. Let's do some graphing first. All right, so 2x squared minus 6x minus 36. Now, I do have a graph, but since it went ahead and put that equal 0 part in there, I'm going to do that for consistency. All right, 2x squared minus 6x minus 36 equals 0. All right, it all comes down to what does solutions means. Hopefully, just looking at the graph that we see something kind of refreshes our mind. Solutions has 3 other names: roots, zeros, x-intercepts. So where it crosses the x-axis is right here. So remember, it's the x value, -3 and 6. Do I see that? Yes, I do. I see -3 and 6 here, and I see -3, 2, and 6 there. Be cautious. Now, where's that 2 coming in? It depends on how the graph looks. Since we added that 0, it did something weird, but watch this. Let's see. If I get rid of that, now I see where that 2 might have come from. Or did we? I'm not sure. That's not what I was thinking, but either way, stick with what the graph was. It's still going to boil down to -3 and 6. See, it's the same thing there. I don't feel like getting into the explanation for this. It doesn't matter for our purposes, but clearly 2 is not one of our x-intercepts. So let's back off of that one. C is the answer. Okay, don't get those backwards, by the way. Moving on. All right. Number 20, as soon as I saw system of equations, I'm thinking I got to graph 2 things. Also, infinite number of solutions. All right. It comes down to what does that look like? Well, hopefully you remember something, but this will may take a little time. But when I'm thinking about graphing a system of equations and infinite, remember we have the cross possibility with one solution. We have the parallel lines. Those don't look parallel, but they are supposed to be. And those are the ones that never touch. They have no solution. And then we have, this is going to be tough for me to draw. Hang on, I messed up my thing here. Let's see. Oh, no. Did I lose it? I may have lost the ability. I'm not sure why I can't highlight anymore. Oh, there it goes. Okay. So remember, if it's on the same line, if it is the same line, they touch infinitely, which means we're looking for the same line. So let me put this back in my split screen mode. All right, so let's start graphing some stuff. So for A, I got y equals -2x plus 4. You got to be willing to take some time to do this. I got 2x minus 4y equals 4. All right, those have one solution, so I'm going to turn those off. That's not it. Now I'm going to be 8x plus 2y equals 30. And the other one for the system for that one is x plus y equals 15. All right, again, they cross. That's one solution. That's not what I'm looking for. I'm looking for infinite. All right, C, y equals 3x plus 4. And its companion was, let's see, y equals 3x plus 4, 3x minus y equals 6. And I see some parallel lines. They're not touching. No solution. That's not it. It must be D. Let's make sure. Y equals 2x plus 4 and 6x minus 3y equals -12. Okay, so I see one line. Let me turn it off and on. All right, there's my red right on top of the black one. Okay, so there we go. D is the lines that are the same. Those are the ones that touch infinitely. So D is the answer. Okay, what are the equivalent? Hey, we got radicals again. Love them, love them. Okay, so just like I've done before, I am going to start with my radical symbols and my whole numbers. So as soon as I see that cube root of 27, let me go get my cube root, move over, and put my index of 3 in there, and put a 27. I feel like I've done this before. All right, so A, I don't really have to do because there is no radical. B, there is a radical, but it is a 3. And then C is also a 3 with a radical. There's no whole numbers in there. And then 9. I don't have to graph anymore or put any more on Desmos. I know it's not 9 because my answer was 3, which means that I have eliminated at the very least, it can't be D because 9 is not going to be a cube root of 27. This comes down to not pairs this time, it's cube roots. We're looking for triples. In other words, if I can divide evenly into a whole number, that means am I going to have anything left inside? 6 is divisible by 3. 6 divided by 3 is 2, which means they're coming out. 3 is also going to be divisible by 3, so those are going to come out. What that tells me is there is not going to be a radical symbol at all. So that means that this one is now eliminated and this one is now eliminated, leaving me with my answer of this. Okay, so that's how it came out. Remember, I was looking for triples. If I divide that by 3, that means there's 2. That means 2 pairs coming out. Over here, we got 3. That's 1, which means 1. I said pair, I meant triples. 1 triple coming out, 1 triple coming out. And there it is. A is the answer. All right, moving on. Oh, scary words. Run, run, run. Come back later. All right, 23. Solve for the equation. As soon as I saw that, hopefully we're graphing these things because too many people miss this. Let's see. Y minus 5. And then over, and I forgot to put my divisor bar, no problem, divided by 2, and equals 3x. There's my graph. Check it out. Now all I got to do is find the match. Y equals 6x plus 10. 6x plus 10. That's awfully close, but that's not it. Y equals 6x plus 5. What do you want to bet that's it? Oop, happened there. I clicked off. Y equals 6x plus 5. Oh, no, maybe. Let's see. Turn that purple one off. Oh, that looks like it's right on top. Let's come back to that one, though. All right, so C, Y equals 3x plus 5. That's clearly not it. And then D, Y equals x plus 5. Definitely not it. Okay, so there is my answer. Y equals 6 plus 5. That would be B. See how easy that was? Too many people miss that, y'all. All right, scary words, scary words. Pass, come back. All right, 25. All right, so we got a fraction equals fraction, known as a proportion. If you want to do it by hand, that's that crisscross, butterfly, whatever it is you do. But I'm going to graph this thing. Put my divisor sign in there. 3x plus 1 over 4 equals, put my divider bar, 2x minus 1. Come to the bottom and put a 5. Look at that. I got a lovely line right there, and I can even pin it. Now, it doesn't matter what that number is. I don't see that over here, but I'm looking for a match. Let's find it. Start matching things. Ax equals negative 9 over 7. Oh, did we get lucky the first time? Let's keep going. X equals negative 2 over 7. Not it. And C, x equals negative 8 over 5. Definitely not it. Last one, D, x equals 0. Well, we know what that one's going through. All right, so let's turn all these off so we can see everything real quick. Make sure we're right. All right, the original green is on. Blue doesn't hit it. Red is right on it. Black is not. Purple is. Interesting. Is it? Let's make sure we didn't make a mistake here. Okay, so let's look a little carefully. Negative 1.286. Now, it looks like a little rounding took place. That one's it. Make sure I didn't make a mistake. X equals negative 8 over 5. Okay, X equals, oh, interesting. All right. X equals negative. I don't know why I saw it that way. That's clearly not it. Okay, so not it, not it, not it. There's our answer. All right, for some reason I had a moment of doubt there, but that's why we double and sometimes triple check if needed. See if we made a mistake or something, but clearly the answer is A. X equals -9/7. All right, moving on. Now, there are some words here, but this one's not really that difficult. Just look at what it's saying. Given the system of inequalities, we got to graph it. Now, we don't really have to graph it since it exists already, but let's graph it anyway, because there might be something that graphing it on Desmos gives us that graph on paper or on the computer does not. So y is less than or equal to x plus 1. That's the first part. Next part is y is greater than negative greater than -2/5, and that's x, and then plus 1. So we got multiple shadings over here. All our lines match. You can see that dashed line, solid line, dashed line, solid line, positive, negative. There's my middle, and I got my 4 zones. Now, over here, we don't see 4 zones, okay? Keep in mind, we have a less than or equal to below the line, and then we got above greater than here. We are looking for the crossover. It's green here, purple here, crossover here. They have labeled A, B, C, D. So our crossover is here. That's B. Here it's B. Let's hope that this shaded area matches the actual letters. I don't like the way this is designed, but they did match up. A, B, B, C, C, D, D, and so on. Since it's clearly B, region B is what I want to see, which just happens to be letter B for the answer. Make sure you pay attention to stuff like that. Either way, this was not difficult. We did have some people miss this, but this should have been 100%. All right, moving on. All right, 27, solution, a system of equations. Okay, that means it's graphing again, right? Okay, there it is, 3x minus y equals 6. That's part 1. Next part is x minus 2y equals -18. Taking a moment to make sure I looked at everything correctly. 3x minus y equals 6, x minus 2y equals -18. These cross. That is the solution, all right? Bring it back, remember, activate it, there and look at it and pin it 6, 12. Do I see that? Yes, I do. That's right there. D is the answer. Please don't get that backwards, especially if you look at it here. It's in order for a reason, X value, Y value. All right, but put it backwards there. Anyway, too many people miss this. I don't understand. Double check what you're putting in there. Make sure you get it right. All right, D. Okay, moving on. 28. Oh my goodness. What are the apparent roots of the graph below? This one I actually do not need my Desmos for because it gave me a wonderful graph. I have to remember what roots are. Roots are zeros, roots are solutions, roots are x-intercepts. Right there and right there. So this one doesn't count. It is an intercept, but it's a y-intercept. But we don't need that. This asks for roots. A y-intercept is not a root. So -1 and 6. I see that right here. And guess what the most incorrect answer would be? -1 and 6, and also throwing in that 4, which is right there, that B. And lots of people picked it. Roots, x-intercepts right there. Moving on. Okay. Now, a lot of people actually missed this one. This is still graphable. We did this way back when it was just one line. Too many people went with what they see right here, but that only works. It points the way only if the variable is on the left side. It is not. And even if you didn't know that, throw this equation in Desmos and graph it, see what it looks like. 13 is less than 1/2, and parentheses 6x minus 4, and look at that lovely graph. You need to know what you're looking at here. Now, 13 less than 1/2 times 6x minus 4. All right, I got a dashed line. Now, we got solid circles, we got open circles, and we got solid circles. Are any of these solid? Doesn't look like it. All right, so that's all indicative of we have just a less than situation here. Now, notice that this isn't really less than on the graph. That's how it read as an equation. But if I solve this, x is going to end up being over here, and it's going to say greater than, because look where my shading is going. Since the shading is going to the right, that means that it can't be A and it can't be C. Both of those are out, okay? The shading matches the arrow direction for B, and it matches the arrow direction for D. Now, look what number they chose. They chose 5 here and something in between 5 and 6. See that circle? All I got to do is come over here and look at my graph, and where did it cross? It crossed at 5. So this is not on 5, that's in between, so that's gone. The answer is B. Too many people miss this. Easy, easy. All right, let's keep moving on. Number 30, we are going fast. Which inequality best describes the graph below? Well, they gave us a graph and they gave us this. Now, I will tell you that's a solid line, and that's also shading below. So since it's less than, it's also less than or equal to, because it's solid. All of these y's are on the left, so we can use that, all right? So y is less than or equal to. I see that here. I see that here. I don't need to do these two because both of those say greater than, which means the shading would be above. So D and B are eliminated. Now, I can figure this out if I want, but let's put it in trusty old Desmos. All right, let's go with A first. Y is less than or equal to 2 over 3 x plus 4. All right, that's pretty clear. Let's do the next one anyway. All right, the other option was C, which is y is less than or equal to 3 over 2 x plus 4. All right, so we need to look carefully now. Both of those cross right there at 4 on the y-axis. Can y'all see that? All right. Now, if you look on the purple line, the second one, it crosses down here in between a whole number. And if you look at this, if you extend that out, that's going to be beyond 5. So clearly that can't be this one because this is less than 5. 5 is out here. So if I come back to this one, that one is -6, which is off the chart. -4, -5, -6. That looks right to me. So that's going to be my green line. And that means that 2/3 x plus 4, that answer is A. Easy peasy. Too many people miss that. All right, 31. Okay, some of us forgot about f of x. Not a problem, not a problem. It's an easy fix. F of x is just another way of saying y equals, okay? So anyway, let's read the question. The function of -2 equals 4. That means y equals 4 when x equals -2. And it's just asking which of the following could be the equation for f of x. Well, since this one, we could type that in if you want. Let's type it in. F of -2 equals 4. Okay. Now, it doesn't like that. All right. Now, we'll come back to that. We don't have to do that. But let's type in these other ones, starting with A. F of x. I could just as easily type y equals. F of x equals -2x plus 4. Got me a line. All right, B, F of x equals -2, parentheses, x plus 4. All right. Now, C, F of x equals x plus 2, and I got a exponent of 2 in there, and then I got a plus 4. All right, my D, F of x equals x squared minus 2x plus 4. Okay, so remember up here, we had this weird little thing, F of -2 equals 4. Okay, remember, this is just another stand-in way of saying y equals. So let's make that say y equals. Now we got us a line. Can you see it? Now let me change the color, make it stand out a little bit better. Okay, there we go. Now let's turn all this stuff off. Let's see what makes sense here. All right. That shares a common point, doesn't it? Let's see if that works. Y equals 4. Is that actually y equals 4? Yeah, but that's not what x equals. Now let's go here. Okay, it doesn't hit that. Let's see what happens. Okay, interesting. We got a curve, and we got that. So it actually gave us a value. So let's go back to this one more time. It said f of -2 equals 4, y equals 4. So when y equals 4, matter of fact, you know what? I forgot to do something. Watch this. When x equals -2, y equals 4. Let's put a point on here. Let's see what happens here. X is -2, y equals 4. All right. Now let's put that out here and let's see what hits that. Okay. My green hits that. All right. So this was kind of useless to me at the moment, other than it goes through there. Did the red get anywhere near it? It did not. Blue, nowhere near it. Green definitely hit it. Purple did not. So graphing that point was useful. All right. So green, A, B, C, that's the f of x. That's the one with the x plus squared. There is my answer. So again, I get it that this could be a little different for some of us. But if you think through it and remember what f of x means, function of y equals, remember, it's essentially giving us a point. The most useful thing to me, at least this method, was graphing this point because it's very clear when only one graph went through it. Graph those points, people. All right, moving on. That was 31. We are rolling. 32, word problems are scary looking. We'll come back to this. And believe it or not, I see the word root, so that's not really that scary, but we'll come back anyway. All right, I see tables. This is not difficult, but you need to remember a few things. First thing I see when I read this, which table does not? I see the word not. That's pretty important. Not. Let me get that out of the way. Not. Make sure we stand that out. Varies directly, not varies directly. Now, if you don't remember anything about variation, I see 4 tables here. What we could very easily do is start graphing tables. Remember, these are just x, y values, right? So x and y, x and y. So I'm going to start graphing. Move this over so we can see it. All right, I'm going to graph this table first. X values. All right, so we got -2 and -1. Use that tab key. It helps you navigate. I got -1 and -2. So -2, -1, -1, -2. Then I got 1 and 2. And then I got 2 and 1. All right, look at what's happening there. All right, let's create another table. All right, for B, X. All right, so I got -2 and -10. Then I have -1 and -5. Then I have 0 and 0. Then I have 1 and 5. Okay, that's my second table. Now let's do 3, which is C. All right, there's C. New table. Start graphing. All right, I got 1 and 10. Don't forget to use that tab key. 2 and 20. I'm seeing a pattern here. 3 and 30. Do y'all see it? 4 and 40. Okay. Now let's do D just to close it out. New table. And my D, X and Y, starting off with 0 and 0, 1 and 3, 2 and 6, and 3 and 9. Okay. Now it might be helpful to make this big this time. All right. Okay, let me get this out of the way. So one thing, hopefully remember how to do on a table, press and hold over this color, turn on the lines. Let's start looking at lines. Did I do it? There we go. All right, that line looks funny. Turn them all on. Let's look for something different. All right, so red, blue. Did we get blue on? Yeah, turn. I may have to zoom out some for it. Oh, what happened with my blue line? Oh, I guess I didn't turn it on. There we go. Okay, so we see all this. Now, look for something that stands out, something that is not, let's go back, not a direct variation or it doesn't vary directly. That means that one of these is definitely going to be different than the others. Okay, so clearly that blue line is straight, that red line is straight, green line is straight, and they look like they're all going through zero. And if you're not sure, this one has zero in it, this one does not. Let's put an extra dot in the blue, put the origin 0 and 0. Yeah, it's going. Okay, this one had 0, 0, it's going. And purple, that's not a straight line, so we don't have to worry about that one at all. Let's go back home. All right, so I think we can eliminate some things. That red line is clearly hitting that, so that is a direct variation, but we don't want that. We want the one that is not. Blue, we added 0 to it, but it's going through the origin as well on a straight line. Done with that. Green, straight line right to the origin. Purple, clearly not a straight line, and it is going through the origin, but it's not a straight line. This is not a direct variation. So let's go back. The one that is not a direct variation was my purple line in my first table. That was A, -2, 1, -1, 2. Yeah, so my answer is A. So that's the correct answer. The other thing to remember is all these things have a constant. The constant for a direct variation is y divided by x. It has to be the same. Okay, so just keep those things in mind. Oh, sorry. Yeah, I got messed up. I was looking at A. So B is a direct variation. Y divided by x. -10 divided by -2, that's going to be a 5. -5 divided by -1, that's 5. Zeros don't count. 5 divided by 1 is 5. All these again, same. 0 doesn't count. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. That's a direct. And 40 divided by 4 is 10. 30 divided by 3 is 10. 20 divided by 2 is 10. 10 divided by 1 is 10. Again, all three of those have the same constant. This one pretty stands out. Just depends on what you know, but that's how you do it graphically. All right, moving on. All right, 34. What is the x-intercept of the line of the equation y equals 2x plus 6? Let's graph it. Y equals 2x plus 6. Okay, and it asks specifically for the x-intercept. All right, well, the x-intercept is not here because that's the y-intercept. Here's the x-intercept. All right, x-axis, y-axis. So let's see if those answers are here. There's 6, and there's -3. You need to know which one's the x. It's very obviously this one. So that should be the correct answer. A lot of people are going to say 6. All right, don't make that mistake. All right, moving on. People did do that. All right, I see lots of words, but is this really, let's see, do I want to come back to this graph of direct variation? You know what? Let's do this one. This one's not as tough as it appears to be. The graph, we just did a variation. The graph of a direct variation passes through this point, 4, 2. Which of the following points will also be on the graph? All right, so let's start graphing. First point they gave me is 4, 2. Now, we also know it must go through the origin. Let's add that. This is one way I could do it. I could also do it in a table form. Right? 4, 2, and 0, and 0. It doesn't really matter. The beauty of the table is I can turn the line on. So we can do it multiple ways. Matter of fact, let's just stick with the table. I'll go back and look at this one in case somebody want to do that. 4 and 2, 0 and 0. So we just need to find one of these that's going to add to our straight line here. Let's see. 2 and 4. Nope, that deviates, doesn't it? 6 and 4. That deviates. 10 and 5. Oh, that looks pretty good. We'll come back to that one. And 8 and 1. Oh, that clearly deviates. Let's go back. So 10 and 5. All right, can we see that that continued our straight line going through the origin? That's the direct variation. That's how you can do it graphically. And I could have done that up here as well if I didn't want to use the table, but I think that table was extra helpful. Now, could you have eyeballed this? I'm sure you could have 10 and 5. I mean, it kind of looks like it is, but I tell you, I would prefer the table because that table really shows. Okay. In any event, that's the graphing way to do it. Keep in mind that the constant is y divided by x. All right, so y divided by x, 2 over 4 is 1/2. 4 over 2 is 2. 4 over 6 is 2 over 3. 5 over 10 is 1/2. 1 over 8, 1/8. 5 over 2, that's the 1/2, and that's the one it was. Okay, C was the correct answer. 10 over 5. So a couple of ways to do it, but the graph is extraordinarily helpful. All right, moving on, moving on. All right, that was 35. Let's go to 36. Find the equation of the curve of best fit. Okay, so again, I think a table will be extra helpful. Tell you what, let's just start over. I messed up my table. All right. So I see all these points. So let's start putting them in here. -3 and 26. I see -2 and 9. I see 2 and 21. I see 3 and 44. I see 6 and 161. Okay, that's really going to get out there. All right, so next thing I'm going to do, start graphing these equations. All right, y equals 13.34x plus 36.20. All right, y equals, this is b, 0.047x minus 1.27. You can already see things eliminate. Y equals x squared plus 3x. Oh, x squared minus 3x. My bad. That's why you double check yourself. And last, y equals 4x squared plus 3x minus 1. Okay, so we need to find all our points. Coming back to my table, don't forget about the zoom fit feature. And also, I'm going to make this one bigger so I can see everything. So let's zoom it all out. All right, so let's turn off all this mess. We got too much going on. All right, so keep in mind this is the curve of best fit. So clearly this isn't a straight line, but is that going to go through the middle of all the data? Depending on how you look at it, maybe kind of, sort of. We'll come back to it. That one, definitely not. Curve, not going through it. Curve, that actually hits all the data. So this is a straight line going through kind of the center, but it really comes down to those words. Let's go back to the problem. All right, it says curve of best fit. Curve of best fit. So purple is not a curve. That's a straight line. The black one, that is a curve, and it hits it very nicely. So there's our answer. If in doubt, go with what makes sense. All right, graph this stuff. That's 36, 37. Okay, so let's get rid of all this. All right, determine the x and y intercept of the linear function. All right, as soon as I see that, I know I'm graphing. All right, so 2x equals 3y minus 9. Okay, and I have these points over here. Determine the x and y intercept. Now, do I need to graph all these? I could. I'm not gonna though. It's too easy. This line has a intercepts right there. So we gotta be careful though. X and Y intercepts. X and Y. Notice that they have these in XY form, meaning points. Those are coordinate points. So I see 0 and 3. Do I see 0 and 3? I see it there, and I see it there. Then I need -4, 5, and 0. I don't see it there. I see it here, but no 0, 3. I see it here. -4.5 and 0 and 0, 3. That also had X intercept coming first with Y intercept. That might be how they do it, X and then Y intercept, X and Y. Just saying, pay attention to those things just in case. Either way, it's very clear. Only one of these has both of these on here. 0, 3 is right there. Negative 4.50 is right there. Easy peasy. All right. 38. I see a graph, and I see this thing here. What is the apparent range? It comes down to knowing what this word means. Remember, we have domain and range. D comes before R, X comes before Y. D goes with X, R goes with Y. So when I hear range, I should be thinking Y values, meaning things going this way, up and down. All right. So let me get that out of the way. First thing I'm thinking is, does this have a minimum or a maximum? These lines are going straight up, but I can see there's a minimum here, so that helps me eliminate some stuff. Okay, so if I have a minimum, that means that Y must be above that, which must mean it must be greater than or equal to. Let's also look at these answers. Ignore this little part for a second, but I see X in here. Right there, I see X. I'm not looking for domain. I see X again. I'm not looking for domain. I see these two. So we're down to C and D. So let's clean this up a little bit. So that means we're only looking here and here. Now, we see that weird little mark. We'll come back to it. Skip it if you don't know it. But look at this. Y is greater than or equal to. That's exactly what this says. Now it says -4. Is that where this is? If I go over here to the y-axis, that's -4. That's it, y'all. This is my answer, D. Now, for what this little symbol is here, that's another way of writing all real numbers. I'm sure there's a fancier way to explain it, but anytime you see those weird pitchforks and R's, that means it's everything, all the real numbers for the range, for the Y. In this case, it is not, but we were able to clearly see what it was by elimination. Range, referring to Y values, okay? Don't get it backwards, because people do. A lot of people did. All right, I see lots of words on this, but we will come back to it. Graphs, it's not that difficult, but had too many people miss it. Okay, what number is this? All right, this is, that one's not even numbered, is it? 39, okay, so this is 40. All right, getting to the end. Okay, so which polynomial, blah, 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 blah. So I see these two things, and I see that little division symbol right there. Now, we don't normally use that, but you can see it. It's perfectly valid. So let's throw this in here in the calculator. All right, so 18n squared. Wait a minute. Let's put that anyway. 18n squared. And keep rolling. Minus 9n plus 1. And I didn't highlight everything. Let's highlight everything. Go to the basement and put it again. 3n minus 1. Okay, no graph. I see a slider. Don't fool with the slider. There's other ways to deal with this, but I'm a big fan of just changing to x. 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 Change every n to x. There's my graph. 18x squared minus 9x plus 1 divided by 3x minus 1. Just remember, when you're done, we're talking about n's, not x's. So let's just start graphing stuff. Remember, 6n is really 6x. 6x minus 1. Oh, we got lucky the first time? Well, keep going. All right, 6x plus 1 for B. Close, but no. C is 6x squared minus 3. And D is 18x squared minus 3. All right, so let's clean this up a little bit. All right. Let's start with D. Clearly not a match. C, not a match. B, close, but not a match. A, there it is, folks. There's my answer right there. Moving on. Look at this system. Okay. As soon as I saw the word system, I know I'm graphing two things. I also see they're only looking for the x value. Some people get this backwards. I don't know why, but this x comes before y. All right, so y equals negative x plus 2. This first part. 7x plus 4y equals negative 1. Take a moment to look at everything. Negative x plus 2, 7x plus 4y equals negative 1. And I see that they are crossing. all right? It's not intercepts, but where the lines intersect, where they cross, right there. Okay, now it said he wants the x value, the value of x. X comes before y. X is -3. There it is, okay? Now, I also see that 5. A lot of people will choose this, all right? But if it said the y value, you would pick it, but that's not what it says. Most people got this right, but too many people missed it. It's easy. All right, moving on, 42. All right, the graph shown below represents this function, blah, blah, blah. F of x equals -1/2 x plus 2 for the values of this. What value does, okay, I don't need to do anything on my graph. I guess I could do something, but I don't think I need to. Okay, actually, let's graph it anyway, just for fun. All right, so f of x equals -1/2 x plus 2. Okay. Now, -1/2 x plus 2. I'm going to do this just to prove it. F of x, change it to y, same exact one. Actually, that's not a good way to prove it. F of x. There we go. Let me do it completely separate. Y equals -1/2 x plus 2. All right. Can we all see that that's the same line? Good. And we'll change this color just for fun, make it stand out. Okay, so coming back over to our graph. What value x, right, the graph shown below represents the function this, for what value of x is f of x equal 4? Remember, f of x is another way of saying y equals 4. So let's type in y equals 4. Let's see what that is. And I changed that color. Let's change this one too. Okay, y equals 4. It's right there. Okay. So this is saying, what is x when y equals 4? Meaning on our line, that red line. So when y equaled 4, meaning on the x-axis or the y-axis, turn off those minor, oh, I already did. All right, so it is right here. Let me debate that one more time. So y equals 4. What is x? That means go toward the line, and there it is. So x is -4 when y equals 4. Do I see -4? Yes, I do. It's right there. The answer is A. Okay. Easy problem. You just need to remember what it means. So graphing did help if you like to do it that way. Did you have to do this on Desmos? No. All the information's right here. All right. You can count up to 4 and then move toward the line until you get there, hit the line, and it is on -4. However you want to do it. All right, moving on, 43. Ooh, words, scary, scary. Moving on. All right, so here we go. Which inequality represents all the solutions of this? Okay, well, I see something that needs to be graphed, so let's graph it. All right, so 9 times 4x minus 8 less than 4 times 6x plus 9. All right, I got some nice looking graph here. Now I need to see the edge of the line. There it is. All right, now they gave me some answers. Now there's a lot of ways I could read this. I could interpret the graph. I know that since it's going to the left, it's going to be less than. It's going to be less than, not less than or equal to, because of that dash. So just eliminating immediately. That says x is greater than it, because the variables on the left side, I can do this. It's not going to be B. It's not going to be D. X is less than. X is less than. All right. What is it? -3 or 9? Well, that should be very simple to see. This line is going through 9. There is my answer. Also, I can prove it. Graph it. X is less than 9. Does that match? Yes, it does. If I had thrown x is less than -3 in here, you would see it's way over here. Clearly not the answer. All right. Easy, easy. Okay, 45. Okay, this one doesn't require anything other than knowing something. The first thing that stands out to me is that word not. Which of the following graphs does not represent a function? So keeping in mind what a function is. A function is one of those things where x's don't repeat. And even if you don't know that, look at the graphs themselves. Let's see if we can get them on this page all at the same time. Okay, so One of these is different than the others. And when I say different, I don't mean the squiggle lines. If we remember our vertical line test or our pencil line test, you know, when you go up, 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 how many times do you hit the line or how many X's appear? All right, if I do that vertical line test on this graph and this graph and this graph, it's never going to repeat. But anywhere I draw a line, it's going to hit that graph twice. See that? That's the one that's not a function, and that's what we're looking for. So the answer is C. Easy, easy. Okay. What are the real roots? And just say roots of this equation. All right, so it comes down to knowing what roots are. Remember, roots have other names like zeros, solutions, and x-intercepts. So let's graph it. X squared minus 7x plus 10. And they threw an equals 0 in there, so let's do that too, just for fun. Now, it didn't like that. That's because I have my bad. X squared minus 7x plus 10. All right, let's change that to red. And there are a couple of things there. What are the roots? What are the solutions? What are the x-intercepts? All right, the x values, 2 and 5. Do we see that? Yes, we do, right there. I don't know how anybody would miss this, but people did. Double check what you put in here. Make sure it's right. Don't get them backwards. Not sure. Even if we look at it with a curve without that equals 0, look what the intercepts are, 2 and 5. Up here, we do have a 10, and that's there, but does that cross the x-axis? No, it does not. Anyway, put what they tell you and stick to what you know, where it crosses the x-axis. Easy, easy. 47, lots of words. I'm going to come back to that. All right, 48. This one is interesting. This one I like. Given the relation, all right, all this. See the brackets, and then we have all these xy coordinates inside. We got this, we got this, we got this, we got this, okay, and so on and so on. Now it says, which of the following values of x and y will make the relation a function? Well, we've talked about functions multiple times. Bottom line is x's can't repeat. X's can't repeat. So all I'm concerned about is the x values in this relation. The y values to me do not matter. 3, 2, x, 1, and 4. What down here is going to make this work? I do not care about any of these y values. Don't care. I do not care. All I care about is these x values. All right. Is 1 up here already? Yes, it is. Is 5 up here already? No. Is 4 up here? Yes. Is 3 up here? Yes. So the only one that was going to work is B, because x doesn't repeat. We don't care about the y's when it comes to this function. Easy, easy. Based on the answers, the majority got it right, but too many people missed it. Easy, easy, easy. All right, 49. 49's got words. I don't want to mess with that. I'll come back. All right, 50, the last problem. Okay, I love it. All right, number 50, given the graph f of x equals 2x plus 4, what are the zeros? I don't care about that word apparent. What are the zeros? Zeros, we just did one. Solutions, roots, x-intercepts. This line crosses the x and y axis. Do I care about that? No, because it's not an x-intercept. I care about that. That is -2. Do I see it? Yes. I also see it here. But 4 is way over here, and 4 is up here on the y-axis. That's not a 0. So that doesn't count. The answer is C. You just need to know what zeros means. We are done. Okay, so this is the first part of the video. I think that's like 38 or 39 questions total that we did in this session. That took an hour and 10 minutes, an hour and 11, so on. So we're right there. I'm just going to leave it there, and let me come back, stop sharing my screen. If you can do those problems, you pass the test. I'll come back with a part 2 with the tougher stuff. I'm gonna go get some lunch, have some pork chops or something. We'll see y'all later. Bye.